We are going to start off today's lesson with a super simple equation. I'll set f of x equal to 1. So I'll draw the y-axis here, the x-axis, and this is the line y equals 1. Now, if we were to take the limit of this function with x approaching any value, then the limit would just be 1 because this function will always approach the value 1. For just one example, let's take the limit of this function f of x as x approaches 3. And that would just be 1 because this function is always approaching 1. Now, let's say we added a constant to the front of the equation and we wanted to find the limit of 6 times f of x as x approaches 3. We would move the constant out, and first we'd find the regular limit and multiply that by the constant. So if we multiplied 6 by the limit we got earlier, 1, we would end up with 6 being the answer. Now I'll set f of x equal to x squared. And I'll graph it right here. So let's find the limit of f of x as x approaches 2. And since x squared is a continuous function, we can just plug in 2 and we'll find the limit to be 4. Now let's set g of x, a different function, equal to 3x minus 2. And I'll try to draw it here. If I wanted to find the limit of g of x as x approaches 2, since it's a continuous function, I could just plug it in again and it would be 4. Now, let's say I wanted to find the sum of these two limits. So I would write it like this. The limit of f of x plus g of x as x approaches 2. So then to solve this, first I would split apart the limits. So I would find the limit of f of x as x approaches 2. And I would add that to the limit of g of x as x approaches 2. So that would just be 4 plus 4, since we found the limits earlier. And the answer would be 8. Next, let's find the limit of f of x multiplied by g of x as x approaches 2. So I'll write that times g of x as x approaches 2. So again, we would split apart the two limits and find them separately. So the limit of f of x as x approaches 2 multiplied by the limit of g of x as x approaches 2. So that would be 4 times 4, which is 16. So next, let's find the limit of f of x over g of x as x approaches 2. f of x over g of x as x approaches 2. So just like we did when we added and when we multiplied, we'll split the limits apart. So on the top, we'll have the limit of f of x as x approaches 2. And on the bottom, we'll have the limit of g of x as x approaches 2. And okay. So that would be 4 over 4, and it will just be 1. And okay, let me try to find some space. Okay, let's say, okay, all right, what if we want to find the limit of a composite function? I want to find the limit of f of g of x, the limit of f of g of x as x approaches 2. So what we would do is first we would find the limit of g of x as x approaches 2, and then we would plug that into f, as if f was a function. So f of the limit of g of x as x approaches 2, and that's just f of 4, since we found the limit before. And since x squared is a continuous function, we can plug that in, and 4 squared is equal to 16. So that's all the work we did, and let me just write down all the properties we discussed. So let's assume we have the limit of f of x as x approaches c, which is equal to L, and then we have the limit of g of limit of g of x as x approaches c, and that's m. So the first property we will write down is the sum rule. So when we try to take the limit of f of x plus g of x as x approaches c, then that would just be the sum of the two limits. And the opposite of that, we didn't discuss it today, but I'm sure you can figure it out. It's the difference rule. So that's the limit of f of x minus g of x as x approaches c. And that's L minus m, the difference of the two limits. So next is what we did at the beginning. It's the constant multiple rule. So if we want to find the limit of a constant multiplied by the function, and we'll make the constant k, then we would bring the constant out, and we will multiply that constant by the limit. So next is the product rule. If we want to find the limit of f of x multiplied by g of x, then that would just be L times m. And last is the quotient rule. If we try to find the limit of f of x over g of x as x approaches c, it would just be L over m. And this is assuming m does not equal 0.